Hello everyone. Today we're exploring some engineering innovations that truly change the world. Engineering is behind virtually every technological advancement we see around us. Let's focus on 3 groundbreaking engineering innovations that have had a major impact on our lives. The internet originated from a military project in the United States called ARPANET in the late 1960s. The idea was to create a network of computers that could communicate with each other, even in the event of a nuclear attack. The key innovation was the concept of packet switching, which is fundamental to how data is sent and received over the internet. Packet switching is the method by which data is broken down into packets, sent individually over the network, and then reassembled at the receiving end. This method allows for efficient use of network resources and provides a robust system where even if some parts of the network fail, data can still be routed through other parts. In the 1970s, the Transmission Control Protocol, or Internet Protocol, was developed. This protocol suite became the foundation for data exchange on the internet. IP is responsible for sending packets of data from the source to the destination, while TCP ensures the packets are correctly assembled at the destination. The domain name system was created in the 1980s, and then the World Wide Web, invented in 1989. DNS is essentially the phone book of the internet, translating human-friendly domain names like google.com into IP addresses that computers can understand. The World Wide Web is actually a service that runs on the internet. It uses the HTTP protocol to transmit data and introduced the concept of hyperlinks, allowing web pages to link to other pages. The impact of the internet on society is profound. It has transformed the way we communicate, learn, work, and entertain ourselves. However, it's also important to consider the challenges and issues the internet has brought, including concerns about privacy, cybercrime, misinformation, and the digital divide between those who have access to the internet and those who don't. The Global Positioning System is a satellite-based navigation system that provides accurate location and time information in all weather conditions, anywhere on or near the Earth. It was originally developed by the U.S. Department of Defense for military navigation, but now anyone with a GPS device can receive the radio signals that the GPS satellites broadcast. The basic principle behind GPS is the use of triangulation to determine a position. The GPS system consists of 24 satellites in precise orbits, approximately 20,000 kilometers above the Earth. Each GPS satellite broadcasts a signal that includes the satellite's current time and position. A GPS receiver, like the one in your smartphone or car's navigation system, listens for these signals. Once it receives signals from at least 4 satellites, it can calculate the user's precise location. The calculation is based on the speed of light and the time delay for the signal to reach the receiver from each satellite. The receiver uses this information to calculate the distance to each satellite, and with distances to at least 4 satellites, it can calculate the receiver's exact position in 3 dimensions. The GPS signal consists of 3 different bits of information: a pseudo-random code, ephemeris data, and almanac data. The pseudo-random code is an ID code that identifies which satellite is transmitting information. Ephemeris data contains important information about the status of the satellite. The almanac data tells the GPS receiver where each GPS satellite should be at any time throughout the day and helps the receiver to locate satellites quickly when it's turned on. Despite its widespread use and many benefits, GPS has limitations. It can be less accurate in dense urban areas or heavily forested environments where the satellite signal can be blocked. Also, it doesn't work well indoors. There are ongoing efforts to improve GPS technology and overcome these limitations, as well as to develop new applications for this versatile system. The Large Hadron Collider is the world's largest and most powerful particle accelerator, located at CERN, the European Organization for Nuclear Research, near Geneva, Switzerland. It's a 27-kilometer ring of superconducting magnets with a number of accelerating structures to boost the energy of the particles along the way. The main purpose of the LHC is to accelerate 2 beams of subatomic particles called hadrons, either protons or lead ions, in opposite directions to nearly the speed of light. These beams are guided around the accelerator ring by a strong magnetic field generated by superconducting electromagnets. The particles are then made to collide at 4 locations around the accelerator ring, corresponding to the positions of 4 particle detectors. The LHC has 4 large detectors. These detectors are placed around collision points and are designed to track the movement and measure the energy of the particles produced by the collisions. Each detector is designed for specific kinds of research. The LHC was instrumental in the discovery of the Higgs boson in 2012, a particle associated with the Higgs field, a fundamental field of energy that permeates the universe and gives other particles their mass. This discovery confirmed a major prediction of the standard model of particle physics and led to the Nobel Prize in Physics in 2013. The LHC is also used to probe the conditions of the universe just after the Big Bang by colliding ions together at high energies. This allows scientists to study a state of matter known as a quark-gluon plasma, which is believed to have existed shortly after the Big Bang. In conclusion, the LHC is an engineering marvel that has already greatly advanced our understanding of the fundamental building blocks of the universe. It's an excellent example of how engineering and physics go hand in hand to push the boundaries of human knowledge. Hope you found at least some of the details interesting. If this is your first time here, we're all about diving deep into the fascinating world of science, engineering, and technology. Be sure to hit that subscribe button and turn on notifications so you don't miss any of our exciting content.